So our next speaker is our great host, Ziv Gan-Or. He's going to talk about a very important topic, classification and penetrance of GBA1 variants and the potential role of modifiers.
Hi, Ari. Okay, so our first speaker has arrived also, so you're going to be right after me. Are you good to go after? Yeah? All right. All right. Okay, so it's not a GBA1 meeting, it's a GBA1 meeting. We will, I will talk about the classification and penetrance of GBA1 variants and modifiers briefly. And starting off with the point that was made yesterday, I do think it's actually very important to classify patients, despite it is true that for a specific individual, whether he has a certain mutation, it's not going to tell you anything about that specific individual. But when you look at patients as a group, the classification holds very strongly, and it has importance both for research and clinical, definitely for clinical trials, which I will also talk about in a second. Talk tomorrow, being the person in charge of the program, allows me to do that. So yeah, that's how it is. So these are my disclosures. And there are basically two main classifications that you can look at in this context of GBA in Parkinson's disease. So there's the American College of Medical Geneticists classification that you probably know. Five categories: pathogenic, likely pathogenic, variant of unknown significance, likely benign, and benign. And this is being done by various types of evidence, clinical data, animal data, prediction of different tools, etc. Usually, if you look at the data sets like ClinVar, for example, it's usually based on Gaucher disease. So when you see a variant in GBA that is, for example, benign or likely benign, it could be for Gaucher disease. So, for example, a variant like E326K or T369M, where you would see it as benign or likely benign, but you know it's a risk factor for Parkinson's disease. And then there is the severity classification that is also based on Gaucher disease, at least in part, in most part, except for the risk factor one. We can classify the variants to severe, mild risk factor, or unknown. So I want to talk a little bit about how we do that. So first, the ACMG classification. I'm not going to go into all the different categories for or criteria for each of these categories. But you can see there are all kinds of numbers and names of criteria. They are being detailed in this paper, where you need to have more than two, strong or moderate evidence and things like that. And that will tell you if a variant is pathogenic, likely pathogenic, etc. This is important, but again, I think that for our purposes, for what we are studying and for the clinical trials that are coming for GBA in PD and dementia, this classification for severe versus mild versus risk factor is potentially more important. So the classification of Gaucher disease into types is also somewhat, in a way, artificial, because like Greg mentioned yesterday, there are patients with type 3 that behave in a way like type 1. They have very mild symptoms, and they like you said, you have a patient in his 50s who was still fine, doing very well. So this could more like of a range of symptoms from being completely asymptomatic, and we see also quite a lot of those with the milder mutations, to very severe form of Gaucher disease that is incompatible with life, that die in utero. But there's still this three categories. It's a bit confusing that it's type 1 here, type 2 here, and type 3 in the middle, but this is just the order by which they were clinically described in the literature. So the three types, the type 1 is the one that we call mild, because it has relatively milder symptoms, although there are type 1 with more severe symptoms, and minimal or no neurological involvement, not excluding Parkinson's disease. Then you have type 3, which is more severe with neurological involvement, and type 2, which is a lot more severe and usually results in death at early childhood. So the classification for severe and mild is quite simple. You need to look at the two alleles two mutations that Gaucher patients are carrying. If they carry a mild mutation, if they have type 1 Gaucher disease, it means that by default they carry at least one of the variants is mild. So any individual with Gaucher disease who has a mild variant will have type 1 Gaucher disease. Those who carry, for example, if you carry one severe mutation, one mild mutation, you'll still have type 1. Those who carry two severe mutations or two null mutations will be, two null mutations is actually non-viable, but one null and one severe they will result in type 2 or type 3, and we call them all together, the null and the severe, as severe. We define them as severe. So this classification is relatively simple. So the understanding that this could also be important in Parkinson's disease, we had it in this is actually my first ever paper as a graduate student, that we noticed that if we look at the same classification that is used for Gaucher disease of these variants, we also see differences in our patient group that was back in Tel Aviv, Israel. So the differences were mainly in terms of risk. You can see that the risk for mild variants versus the risk for severe variants in our cohort was quite significant. The difference at age at onset was not that big. It was a bit over 2 years earlier, but not as big as we see in some other populations. Then the year later, this very large study came from the UK. In this study, they just reported what they find in terms of GBA mutations, but they did not classify them based on severity, which was nice for me because then I could reanalyze the data and write this letter. And when I reanalyzed this data, I saw basically the same thing. In this case, the differences in age at onset were much prominent. So those with mild mutations, they had age at onset over 62, and those with severe mutations in this cohort just below 50. So that's a very big difference. Also, what I noticed is that they also had data on cognitive decline, and in patients with severe mutations, more than half of them had cognitive decline, and about a quarter of those with the mild mutations had cognitive decline. So just to confirm that this is a real thing and that it's important, a few years later we did this meta-analysis where we analyzed all the available studies that were done by then. So this was published in 2015. And again, we classified all the patients based on their, if it's mild or severe variant. At that time, we ignored E326K and T369M. And we found this. We found that mild variants, the odds ratio was about 3-fold, and severe variants, it's about 14-fold. Now, if you think about mild mutations being, if you think about the lifetime risk of Parkinson's disease, which is about 6%, your chance of Parkinson's disease in your lifetime is about 6%. So as odds ratio of 3 will increase it to around 18%, which is in line with what we know about the penetrance of GBA mutations, that is probably between 10 to 30%, and I will briefly talk about it later. And the same thing about age at onset. When we analyzed the data from these meta-analysis, the available data, we saw these differences, that non-carriers of GBA1 mutations had an average age at onset over 60, 58 for mild mutations, 53 for severe mutations, and homozygous and compound heterozygous had an average age at onset of 50. So it was quite clear then that this is a real thing, these differences. And I will talk more about their importance in the clinical trial setting tomorrow. Then there was more attention given to these two common variants, E326K and T369M. And these mutations, these variants, they do not cause Gaucher disease or do not cause clinical Gaucher disease, but they are associated with increased risk for Parkinson's disease, with about this very similar odds ratio to the African variant that we just talked about. between 1.5 to 2, the odds ratio. So these we call them risk variants. So if you see in papers people talking about severe, mild, and risk, these two are the risk variants that we refer to. Now, when we look at cognition, I told you what I found in that when I reanalyzed the data in the paper, but after that there were papers that did much better job in terms of analyzing longitudinal data, and the effects are also very clear. So here on the left you can see these are non-carriers of GBA mutations, and overall GBA mutations here in red, they do progress faster to dementia, to have cognitive decline. And if you divide them by severe or mild, so the mild carriers are here in between, and the severe carriers are here in yellow. So it's quite clear that those with severe GBA mutations progress, the cognition decline is faster. And this is another study showing essentially the same thing. Here they also included risk variants. So in blue, these are non-carriers. Then you have the risk variants in green. Then you have the mild, and then the severe mutations. So again, the same effect seen. And this is really important, especially again when considering trials that their outcomes are also include cognition. In terms of penetrance, there are quite big differences between different studies that you can see here in this paper from 2020 that summarized everything. And you can see that in different studies by the age of 80 to 85, the penetrance varies between 10% to 30%. What you can also notice is that the source where the data came from is important for the penetrance estimate. So studies that used individuals that came from Gaucher disease clinics, so studies that, for example, took parents of Gaucher disease patients and followed them up and estimated the penetrance, they had lower penetrance compared to these other studies, and these came from Parkinson's cohort. So in these studies, they had patients with Parkinson's disease, and then they looked at their family members of those who carry GBA mutations, and so over time, how much time and at what age they develop Parkinson's disease. So you can see that those from Parkinson's disease, the estimates are larger, and the reason is probably because these families have Parkinson's disease. So in general, they have also other genetic factors, or if you'd like, the polygenic risk score for Parkinson's disease will be higher, and that affects the penetrance, and maybe also environmental factors that are shared between the family members that are relevant for Parkinson's disease are more relevant here. So the population from which the studies are coming is important, and we don't know what's the actual penetrance. It's probably somewhere in between. Might be closer to the Gaucher disease estimates, because these are not biased by the high polygenic risk score that we see in Parkinson's disease. So if I had to guess, I would say it's probably between 10 to 15, maybe a bit more, but that's more of a guess, and we will need population-based studies to see that. Another important thing to mention is that dementia was not estimated in many of these. So there's also penetrance to dementia with Lewy bodies that was not included in this. So the penetrance will be slightly higher. So for the classification, we created this browser that you have the QR code here, and this paper came. Is Jem here, the first author? I don't know if he's in there. Yeah, hi Jem. So Jem did a lot of work. He back then he was an undergrad student. Now he's a graduate student in my lab. A lot of work to put this together with the team of Cornelis from the NIH. He had to manually find all the variants and go to the literature and see how they were classified in Gaucher disease. And we came up with this browser. The reason we did it was because I got sick of getting emails from companies asking me, oh, is this a severe mutation, is this mild mutation? Okay, I will just put it on a website. And then now I just send them the link and let them figure it out. And we update this website every once in a while. The next update will be in the next couple of months, most likely. We're basically waiting for the ROPAD and PD generation studies to be published, and then we want to include these variants in the next update. So what you get in this browser, if you go in, you get all the variants in GBA that have been reported in PD, so not in Gaucher disease, in PD, and their classification. And then you have a search area here where you can search for specific variants. So I search, for example, for L444P, and then you get different information about the variant, their classification, pathogenic and severe. You get also information about their allele frequency in different populations, odds ratio that reported in different studies, all kinds of prediction scores, so for severity of the mutation and for the conservation of the mutation in evolution conservation, and also you get a manuscript that reported it in Parkinson's disease. If you go to the About section here of the browser, you get this pop-up window, and you can simply download all the background information. Instead of searching one by one, you can simply download it, have it as an Excel table on your papers, and don't send me emails about asking for it. Yeah, no, I'm joking. I'm happy to get these emails. And also, if you use it, please, it will be nice if you cite it. Last thing I want to talk about in the next couple of minutes is GBA modifiers. How am I on time? Okay, so 2 minutes, okay. We have all these genes that have been that are here. Some of them have already been discussed, so I don't want to go into them in too many details. I'll just mention a few very briefly. These genes or variants in these genes can affect either the penetrance of GBA, so the risk, or the age at onset, or the enzymatic activity, or the biology of GBA, and we know that from different studies. And it will be very important to take these into considerations again when you think about clinical trials and when you think about other types of studies, that you really want to know what's the entire background of specific individuals that affect their risk or their disease progression or the mechanism. So just a couple of examples, and I will end with this. For example, this study that was done by Cornelis from the NIH, very large study focusing only on GBA carriers, PD, DLB, and controls that were analyzed. And the two top hits that came up is affecting the risk for conversion of GBA carriers were in the synuclein region and the cathepsin B that was mentioned already. So, for example, in our hands, and this has been also reported by Dimitri Cranch group, not in neurons, but in other cell types, but what I'm showing here is in neurons. When we knock out cathepsin B, we see that it reduces the activity of GKs in dopaminergic neurons. The same thing with TMM175. This is another important modifier of GBA. The risk variant for Parkinson's disease, this here is still unpublished, but it was published. Similar findings were published by others. Again, not in neurons. This is in neurons, where we see effect of M393T on enzymatic activity of GKs. The same risk variant for Parkinson's disease also affect the age at onset of GBA-associated PD. So we demonstrated it here, but also it was demonstrated by Cornelis previously in this GWAS. So just to summarize, I mean, we talked about the classification. I hope that the classification now is clear for everyone. And I will talk more about why these are important for different clinical considerations in my talk tomorrow. With this, I will end here. I would like to thank my team. And when I reached about 80, 90 different collaborators, I decided to stop, and I just put the main symbols here. And so we have a lot of collaborators from internally at McGill, GP2, mainly Andy and Cornelis, Alistair Noyce and others, the NIH. We also work with Ellen and others. IPDGC kind of transformed into GB2, but we still use a lot of the IPDGC data, and the International RBD Study Group that we also lead their genetic studies. Thank you very much, and if we have time for questions, I'll be happy to take them. If we don't,
we'll do one quick one.
Yeah, and you are welcome to come and catch me in the break and ask more questions if you'd like.
Send an email. He loves emails.
I love emails.
So I'm still a little bit confused about what the mutation matters in the cognitive issue, and a part of it is a lot of your early data didn't use what you're calling the risk alleles, the E326K and T369M. Because we just heard the presentation from Sonia, and those are really common in dementia with Lewy bodies. So clearly, they are associated with poor cognition. I'm worried that some of the problem is classification, that you may be excluding them by excluding the DLB population of carriers.
Yeah.
So it makes it very confusing, because there's no question that you can have those mutations in severe cognition.
Yeah, no, you're absolutely right, and you're right. We will need to do this in dementia with Lewy bodies. We need a lot more studies to understand that. Maybe this classification is less relevant in dementia with Lewy bodies, for example, specifically. I don't know, but in terms of deterioration, cognitive deterioration in PD, I think the evidence is quite strong. But you're right that if we're looking at isolated dementia or just cognitive decline, whether in PD or not, we could be a bit biased by the lack of studies, and it's possible.
You're stratifying for studies. There's just so many exceptions that I think you really have to be careful. I mean, when you can see so many patients with the same genotype that have such different Parkinsonian features. So, I understand your desire to be able to group people, but I just think you need a lot of caution.
Yeah, again, at the individual level, you're right. You're absolutely right. But if people want to do clinical trials and they have 400 patients, and they know that severe mutations progress as a group, again, not individuals, progress in a certain rate, and mild mutations progress in a slower rate, and they don't take this into account when they design their trials, this would potentially could lead to bias of the results of the trial. If one group has more severe mutations and as a group they progress faster, it will affect the trial results. So this is actually very important, and I will talk about this tomorrow.
All right, thank you, Zib. All right.